In this problem, we're going to find the voltage V0. We're going to use a problem-solving strategy entitled AC Steady State Analysis. And if we look at our circuit, we've got a single source, and we've got several impedances. And what we'll do is we'll reduce this circuit down by combining impedances and admittances. And once we reduce the circuit, then we'll do some analyses to calculate the voltage. So if we look, for instance, let's start. We've got a couple of impedances in series here, and they're going to be in parallel with this impedance. So let's calculate an admittance Y. It's a parallel combination of those. So Y then is 1 over J2 plus 1 over 2 minus J2, and that's 0.25 minus J.25 Siemens. Okay, so that's net admittance. Now let's convert that to a Z. Z is 1 over Y, and that's 2 plus J2 ohms. So now let's redraw our circuit with that combination. So here's our source. It's 2 at an angle of 0. Here's this impedance on the right hand side of the circuit. Now, in this circuit we can use current division. Let's use current division to calculate the current I2. So by current division, I2 is 2 at an angle of 0. Now we want the current through this branch, so we're going to put this impedance in the top. So we have 4 minus J2 over 2 plus J2 plus 4 minus J2, and that gives us 1.333 minus J.667 amps. Okay, so there's the current I2. Now let's back up to our previous circuit, and if we look, we've calculated this current I2. What we really need is this current I'll call I0, because if I have that current, then I can calculate that voltage. So let's do current division again. So I0 is I2 times, we want the current through here, so we're going to put the J2 in the top. And that gives us an I0 of 0.6667 plus J 1.333 amps. So now we have the current which flows through this element, because if we apply KCL here, that's 0. Now if we look for a second, remember, bringing back to Ohm's law, we have an element Z, and we have a voltage V and a current I. If the voltage polarity and the current direction is shown, we can write V as equal to Z times I. Now, notice here in our circuit we have I0 flowing up this way. So if we want to satisfy this convention, we have minus I0 flowing in that direction. So V0 is minus, minus J2 times minus I0. So that's really J2 times I0, And V0 then turns out to be 2.98 at an angle of 153.43 degrees.